Okay, the last part of this chapter, yeah, I kid you not, this is the end of the alkynes chapter. It's a really short chapter because you know so much already. You knew everything there was to know about alkenes, and alkynes just take it with one extra double bond, or one extra pi bond there, so this is really good. Really nice, easy, quick chapter. The last part of it involves synthesis. Once you get into organic 2, we're going to do a lot more work with synthesis. But basically, here's the deal. The reactions we've learned so far are SN1, SN2, E1, E2. We've got our alkene reactions. Now we're looking at alkyne reactions. We got our reactions of alcohols. How can we use those various reactions to make different molecules? Make molecules that we think, oh, I think this molecule will have different properties and therefore will help us. Taking some other reagents, combining them together to make a different molecule. This is synthesis. We didn't quite get it, but recall the acetaminophen lab. If we had a chance to do that, we took two reagents that together don't help a headache, and you'd make acetaminophen, essentially Tylenol, which does. So that's the deal. Let's look at synthesis. And the way most chemists do synthesis is not starting at the beginning and figuring out what I can make from this. You usually have a target molecule. Here's a molecule I want to make. And the question is, how do I make it? You start with the answer, I need to make this molecule. The question is, how do I make this molecule? And it turns out one of the best ways to do this is what's called retrosynthetic analysis. You start with the product and then say, okay, here's the product. What reaction happened immediately before I got this product? What things did I react together immediately before to make this final product? Okay, then look at those two reactants, and then how did I make each of those reactants? And you keep going backwards till you get to something that's you can buy or easy to make or something like that. And because in our analysis we're actually working backwards from the way we'd actually synthesize it, instead of our normal arrow, we're going to use this special arrow right here with the point of the arrow and two lines. When you see that arrow, that means retrosynthetic analysis. It means the synthesis you did, the steps you took, the reaction that you did actually runs the opposite direction that this arrow shows. We're just starting with our product and moving backwards. Okay, and there are two main categories of reactions: forming new carbon-carbon bonds or converting one functional group into another functional group. And a lot of the time you're converting one functional group to another functional group so that you can use it to form a new carbon-carbon bond. Alright, so we're going to start off easy because our only carbon-carbon bond forming reaction we know right now is our acetylide reactions. So let's look at this. Here's the deal. This is what you want to make. You want to have this terminal alkyne, 1, 2, 3, 4, 5. So this is 1 pentyne. But you don't have 1 pentyne. All you have is acetylene, because you can buy that pretty cheap, acetylene gas. And you have other inorganic or organic reagents. So starting with acetylene, how do you make this? The best way? Retrosynthetic analysis. Starting with this, what reaction can you see would have made this? What reaction can you see that would have done something to make this? And you might be able to look at this and say, wait a minute, I know that I can form this carbon-carbon bond. If this was HC triple bond C negative, the carbon ion, and if I had a halogen on here, I can make this bond. So we call this is our first disconnect. We said, okay, this is the bond I want to make. Retrosynthetically, that would come from, this acetylide ion and this alkane, well actually an alkyl halide, probably a bromine or carbon on there. All right, and so, okay, well, this, let's say we could buy this beast right here, but how would you make this? You can't buy acetylide ion. How do you make acetylide? Well, that comes from deprotonating acetylene. So if we worked our way backwards, we can say, all right, this is the retrosynthetic analysis. Here's the product we want to make, and we can make it by reacting these two, and we can buy this, and we can make this from here. And so the forward reaction when we get in the lab, the synthesis we would run is start with our acetylene, add NaH or sodium amide here to make the carbanion, the acetylide ion, then react it with this propyl chloride and do our SN2 substitution and make that product. Now that was pretty easy, pretty straightforward. Let's do something a little bit more involved. Really tax the brain a little bit here. How do you make this guy right here, 2-butanone, from compounds having 2 carbons or less? Oh, well, let's see. This is a butanone here, and no ketone. Have we studied how to make ketones? We know how to make ketones? Wait, I remember we just looked in our previous video with the alkyne reactions on how ketones are made. Ketone is the tautomer of the enol. And so I know that this would be the product if I had an OH here and a double bond here. If I had an OH here and a double bond here, that's an enol. So how do you make an enol with a double bond here and the OH here? That's right, that is acid catalyzed hydration of a terminal alkyne. I know if I had a terminal alkyne and I added H2O, sulfuric acid, and mercury 2 sulfate, I would get this, because I'd make the enol, which would tautomerize to this ketone. So, then how do I make this? Oh, well, here is carbon with a hydrogen on it here. I bet I could make this just from our one above here if I did a disconnect right here. This is the bond I need to make, with this being my carbanion and this having a halogen on it. And so I know I can have CH3, CH2 with a halogen on it, plus my carbanion here with a CH on it, and that would make this right here. Okay, well, how did I make this beast here? That's right, from acetylene and sodium hydride. So the retrosynthetic analysis, we start with our product, ended up with the reactants that we can buy. And so the synthesis then would be the reverse of the retro. You take acetylene, take off one of these hydrogens to make the carbanion, attack this chloroethane here, and then you get this beast right here, terminal alkyne, do the acid catalyzed hydration, forms the enol. Recall, hydrogen goes here, OH goes here, Markov-Nikolson rule, and that will tautomerize to the ketone. When you get to organic 2, we'll be doing lots of other things, and there'll be questions. Okay, here's my product. How do you make it? Try to do it in less than 10 individual steps. Things are going to get more complicated, but don't worry, your brains are going to be much bigger by that time. Well, that's it for the alkyne chapter. We will now move into, in the next video, redox reactions. Oh, that sounds like Gen Chem 1 stuff. Not really.